Okay, so let's go in Roadway Designer and take a look at some of our options there for overlay projects. So I'm going to make a new corridor. I'll name this CLPS 185 overlay. And I'll pick my chain and profile, and I will give this some station limits. And we'll add that in. And for the corridor, I'll define a template drop every 12.5 feet. I'll use that template for State Route 185. Okay, so my template PGL is meeting the existing ground profile. So you can see right here at my PGL point, I'm sloping at minus 1.6%. And then I've got my orange stripping component in there, or pavement planing component in there. So it's the top is meeting existing ground, it's going down 1 inch and stripping that out. So I need to do a couple things to get this working. First thing I want to do is I want to bring the saw cut point here up to meet the existing cross slopes. And then once I've got my cross slopes of my proposed meeting the existing, I'm going to move the whole template up the thickness of my 2 pavement layers. So I'll move it up 3 inches. So I'm going to use the overlay mode to do that. So that's the first scenario I'm going to look at, is just overlaying the slopes that are out there and matching the slopes that are out there. The second scenario I'm going to look at is maintaining this 1.6% slope and doing some cross slope correction, and then getting into defining the profile based on some critical points on which side is higher or lower. So let's look at the first scenario. And lower right display mode, we have an overlay mode. And if I click overlay mode, dialog reconfigures into 4 areas. I've got plan, cross-section profile, and super elevation. And the overlay tools are available. So we're going to go through each of these 4 options, and I'll start with my cross slope optimization. So it's allowing optimization based on feature names or alignments. Alignments will be used with GeoPack. And my pivot alignment is my center line 185, and I'm going to define my cross slope for the left and then for the right as 2 separate steps. So I'll pick my saw cut left as my super elevated alignment. And again, the idea here is to bring the top of the pavement up to meet the existing at that saw cut location. My design type can be defined by a control line or a constant. I don't have any control lines defined. That would be a super elevation control line. So if I had already defined super elevation for this, I could use that as my starting point and then come in here and have it do some cross-section analysis based on my super elevation slopes versus the existing slopes. So in this case, I'm going to tell it to use a constant value of a 1.6%. And we'll have it compare that to our existing pavement slopes. And I can give it some optimization parameters here, either an elevation tolerance or a maximum delta G difference value or a slope tolerance. So what I'm going to do is run this a couple times just to show you how that slope tolerance works. So I'm going to start with the default value of 2%, and I'll just go ahead and tell it to calculate the correction. So it's going through each of my template drop stations and analyzing my existing ground slope, and when it's done, it's reported the values here. So there's the existing ground slope on the left side for my existing road, and there's my design slope was a constant 1.6%, or like I said, it could be defined by a super elevation control line. And if I had a control line established, it would show me the cross slope for that control line. And now it's showing me the difference between the existing ground and my design slope, and it's showing me a corrected slope. So what it's done is it's taken that 2%, and since I'm outside of the tolerance of 2%, it's taken the ground slope and going up 2% to come up with this corrected value of 1.11%. Now I can manually change that here if I want, or I can come back in and just change my tolerances and try processing it again and see what kind of results I get. So that's really up to the designer to discern what they want to do there. Down at the bottom, there's some buttons here just to scroll through the sections and go back or forward. And there's also one here to go to the station with the largest difference. So they're at station 46 plus 47.28. The difference on the left side is the largest one there, 3.94%. But what I want to do for our example is I want to just tell it to constrain it to match my existing ground slope. I'm not going to use any corrected cross slopes. So up here on the tolerance, I'll just use a 0% tolerance. And I'll reset my results and tell it to go through and calculate those again. And now here's the results, and again it's showing me my ground slope, my design slope, and the difference. But this time my corrected slope is matching my ground slope because I'm not giving it any tolerance value there. So through my sections here, if I scroll down through, you'll see that the ground slope here matches my corrected slope. So if I want to go ahead and apply that, I can just enter a new control line name down here, and I'm going to give it the name of that section. I'll just use my center line proposed stay route 185 as the name of the section, and the control line I'll call this left saw cut. So this is a super elevation control line that it's going to create, and it's going to make I'll tell it which point to constrain to these slopes when I hit create. So my pivots, my PGL, my super elevated points, my left saw cut. So I'll hit OK, and that's applied. And you can see over here it has moved my pavement up. And zoom controls don't want to work while I'm in this dialog. But it has moved my pavement up to meet the existing. So let's do the same thing for the right side. So I'm going to reset the results, pick my alignment, and this time my saw cut right. Have it calculate the correction, and again I'm just going to accept the values. We're meeting the slope with a 0% tolerance, and this time I'll make a control line for the right saw cut, and my point will be right saw cut there, and you can see now it's brought that up to meet. So that's the first step, is defining my cross slopes by having it meet my existing ground. And as I scroll through these, you should see my sections follow the ground. Now some of these slopes aren't desirable. You can see a pretty steep slope there, -3%, but we'll take a look at correcting cross slopes in the next example. Okay, so the next thing I want to do here is I want to raise my profile up. So I want to put my pavement on top of the existing ground. So under Overlay Tools, the next thing is my vertical adjustment settings. And I can give it a backbone thickness and a minimum overlay value. So my thickness is 3 inches. And I'm going to use an overlay value of 0. And my range is from the left saw cut to the right saw cut. And I'm just going to go ahead and apply that. And I have to move to the next station for it to actually show it. But you can see now that it's moved my profile, proposed profile, up 3 inches, and my pavement's on top. Okay, so that's looking pretty good. That's what I wanted to accomplish with this. Now, it has not saved that profile. It's just a profile that's been kind of defined in memory for that. So the next thing I need to do is go ahead and tell it to smooth the profile if desired, and then apply it, which will actually save it into the ALG file. The smoothing can be used to set a tolerance value. So in this project, or for this example, I don't want to smooth it. I'm just going to meet what's out there and just overlay whatever's out there. But you may want to do some profile optimization where you can smooth it out, and you can give it a tolerance value and allow the software to generate a smooth profile for you. And maybe if you said, well, I want a window of 3 inches, you could give a tolerance of 0.25 or 6 inches, tolerance of 0.5. And it will use that as an envelope window to kind of smooth out the profile between there. But I'm just going to tell it match what's out there, so a tolerance of 0. And as far as the name of a profile, I'm going to give it a PGL CLPS 185. And since this is the overlay portion, let's say overlay. That may be too many characters. Yeah, GPK file won't accept that. So we'll just do OL for overlay. And close this. And I do have to tell it apply the adjusted vertical alignment here in order to store that alignment. And there's a style defined for this. It really is irrelevant for our purposes. I'll just give it our generic feature line. And here's where I could have it create vertical alignments for the top and bottom of the envelope that was generated. Had I given it some tolerance settings there. And the nice thing about it is, once you've stored this profile, and if you create the top and bottom envelope, you can export those back to GeoPack, take it into the profile alignment generator, and plot those. And then you can go in and manually make some edits to your profile yourself and use the envelope as just references to see, when you're manually editing, that you're going to stay in between those limits. Well, I'll just go ahead and OK this. And got lost. There it is. So at this point, the profile has been applied and it's been stored in the ALG file. And again, I could export that profile to the GPK file if I wanted to. So if I go back to normal mode here, I can scroll through my sections and just see how that was applied. And looks good. That's what I was hoping to achieve. Whether it's good design or not is another question, but it serves the purpose for our example. One of the things that they've added is some component quantities, and might as well talk about that now. Under Tools, there's a component quantities option, and sometimes this dialog wants to open up a little funny. It's really big. If I close it and try and open it again, that's more the size it should come in at. I'm on my first section. As I move forward, it's showing me volumes between that first section and the current section. And it's showing me volumes for each of my components. And that's the style that was defined for each component. And I haven't really talked about that yet either. In the, I guess what would be July 15th, 2011, here in a couple weeks, our Design Resource Reference Center update. I've made some changes to our components and our levels. Our component names were generic for the pavement layers and the shoulder layers. Just component or CM underscore P underscore pavement 1, pavement 2, pavement 3, 4, 5, and 6. Same thing for shoulders, shoulder 1, 2, 3, 4, 5, 6. What we've decided to do is make it a little less generic. So we have a pavement surface for our surface course, an intermediate 1, and there's an intermediate 2 available, and then a base 1, base 2, and there's also a base 3 available. Same thing for shoulders. So there's a shoulder surface course, intermediate course 1 and 2, and base course 1, 2, and 3. So those are still generic. They're not specific pay items, but they are starting to narrow down a little bit into different pavement types. So at this release of the software, there's really no support for pay items here, so we can't go that far yet, but we do have enhancement requests into Bentley to allow defining pay items for our components. And another thing you'll notice here is the volumes are reported as cubic feet. And that's another change request we have in with Bentley, is the ability to user define whether we want cubic feet or cubic yards. But what I want to look at with component quantities is for each of these I can define a unit cost, and then it'll give me a total cost for the material and an estimated cost for the entire project. So I have no idea what an appropriate cost value for any of these would be, but let's just maybe go in our pavement surface and say that's $1 per cubic foot, and I could define values for each of these. And as I scroll through, it's just going to accumulate my total volumes for the stations and show me the total so far, and then down here the total cost. So for each of these units or these items, if I want to put in a value, and again I have no idea So I'm just putting something in that may make absolutely no sense whatsoever. Oops. Okay, and what I'll do is just go to the last section here. So for those unit costs, I've got approximately $31,000 in my payment. So if I wanted to make changes to my design, I can come back through here and take a look at that, and I can see how those design changes impact the cost for the project. So I'll go ahead and close it and leave it at that.